Welcome class 10th. In the topic work, energy and power, today we will discuss about mechanical energy and its different forms. What is mechanical energy? The energy possessed by, this is mechanical energy. The energy possessed by an object due to its state of rest or motion. It is called energy, mechanical energy. So, the energy possessed by an object due to its state of rest or of motion. How will you define? It is found in two forms, potential energy and kinetic energy. Now, the forms of mechanical energy we discussed, potential energy and kinetic energy. Then what is potential energy? It is the energy possessed by an object in its position of rest. In changing its position, whatever is the energy acquired by the object, that is potential energy. When its shape or size is changed, then the energy acquired is called potential energy. Then how will you define the potential energy? The energy possessed by object at rest in its changed position or change in size and shape. This is called potential energy. Then I am not going to write here, you can define yourself the energy possessed due to change in position or change in shape or size. Now, this potential energy is categorized further into two parts, gravitational potential energy, I will write with the symbol UG, and elastic potential energy. What we discussed earlier about the potential energy, due to change in position of the object, that is gravitational potential energy. And what was the definition? Or change in shape or size, then this is elastic potential energy. Then how to define? Learn it, that potential energy in general, the energy possessed by the object in its change of position or change in shape or size. The change of position, this gravitational potential energy, and change in shape or size is elastic potential energy. So, due to change in position of the object, the energy possessed is gravitational potential energy. And you know, at infinity, this potential energy is zero. Why? Because force of gravity is zero. Force of gravity is zero, so potential energy is zero. What does it mean? That gravitational potential energy, how will you define? It is defined at a point. This I am writing gravitational potential energy UG. Then UG is at a point is defined as work done by gravitational force in bringing an object from infinity to that point. What is gravitational potential energy? Suppose this is the surface of earth, and from the surface of earth, here you suppose this is infinity. Then if an object is brought from infinity to a point, suppose at this point A, whose height is h, then gravitational potential energy at point A at a point is defined as work done by gravitational pull, gravity of earth, to bring then that object from infinity to that point. Here at the surface of earth, we assume that potential energy is 0. Actually it is not 0, we assume that from the surface of earth we measure the height. So if at the surface of earth UZ is 0, then we can say that if an object is raised from the surface of earth to the height h, then how much energy it will acquire, that will be mg into h. Mg, the force with which the object is raised and up to the height h. So at A the potential energy is mgh. So in general, how the gravitational potential energy is defined, why it is negative. So look that since the gravitational potential energy is defined as the amount of work done in bringing that object from infinity to a point in gravitational field, then since the force is used here, the work done by the force is force of gravity, and work done by the force is force of gravity, that is force of attraction. Therefore gravitational potential energy is negative. Learn always that force of attraction is negative and repulsion is positive. So gravitational potential energy is negative. Whenever from the surface of earth you increase the height, then gravitational potential energy also increases. But how the gravitational potential energy at this point A, this is. Now if you see that an object is falling freely, suppose this is the height h1 at which the object was, then this is the, now this is the height h2. Then how will you find that what is the loss in energy? If you find that loss in energy, then it means initially the object is here, initial position, then you will find potential energy ui, that is mg h1, you will write here. And at this position what is height h2, so final mg h2. Then loss in energy when the object is coming down, then this loss in potential energy can be written as mg h1 minus h2, that is u initial minus u final. And whenever you throw an object upward, suppose this is the object, it is thrown upward, so what happens? As soon as it will acquire height, it will gain potential energy, and you throw the object with certain velocity. So initially the potential energy, and suppose it comes here, then from here to here it reaches, suppose initially this is the height at point A and at point B. The object is thrown vertically upward direction. Then what happens that if this is the height h1 and this is the height acquired h2, then gain in potential energy, how will you find? This will be u final minus u initial. What is final? This is mg h2 and this is minus h1. So in this way you can find that how the gravitational potential energy is calculated. Normally whenever the potential energy is seen in going the ball in the upward direction or downward direction, we find as the ball attains certain height, height is increasing, potential energy is increasing, but which energy is decreasing? Kinetic energy. Similarly, from certain height, if the ball is dropped, then height is decreasing, then potential energy decreases, and it is gaining certain velocity, so kinetic energy increases. That means potential energy is converted into kinetic energy. How can you give the examples, other examples? Look, you have seen the spring. If you compress the spring, then in the state of rest, whenever you have compressed the spring, then the work done in compressing the spring is stored in the form of potential energy. Bow, if you see the bent bow string, is how much it is stressed, that maximum will be the kinetic energy when the arrow is released from the bow. So these are the examples when potential energy is converted into kinetic energy. What is elastic potential energy? First, you know what is elastic behavior. Whenever deforming force is applied on an object and its shape is changed, suppose you have rubber ball, you press it, its shape changes, and whenever you remove the deforming force, it regains its original shape or size. Then what is elastic potential energy? The elastic potential energy is the energy possessed due to change in shape or size of an object. How will you define elastic potential energy? Whenever the deforming force is applied, then work done by this force is stored in the form of elastic potential energy, and whenever the deforming force is removed due to this elastic behavior, the object acquires its original shape or size. So the elastic potential energy, gravitational potential energy, we have seen here in the two forms of potential energy. What about kinetic energy? You know, kinetic energy is the energy possessed by an object due to its motion. Yes. How will you say that work is related with kinetic energy? We have read work. You know, work done which the moving body can do before coming to rest, that is called kinetic energy. Whenever ball is coming towards you, then you apply certain retarding force to catch, your hand applies a certain force to catch it. So whenever the kinetic energy is to be defined, then you can define kinetic energy as the work done which the moving body can do before coming to rest. Kinetic energy can also be calculated by an opposing force to stop the body. How will you find the kinetic energy? Its expressions, look here, that kinetic energy is equal to, suppose you are stopping a moving ball by applying some retarding force and ball has moved up to the distance s, displacement. Then you know this retarding force can be written by F equal to ma. Initially the ball was moving with the velocity v, and after moving the distance s it is stopped, then the velocity becomes 0. Then you know v square equal to u square minus 2as. What will be s here? You will find here s, this v final velocity is 0, u is initial velocity, we have taken here this v, then this is s is v square upon 2a. This is initial velocity and this is final velocity. So this is final and this is initial. We have taken initial velocity, this is u with the value v, and final velocity 0. How have you got this expression? Look here, 0 equal to v square minus 2as. So s is v square upon 2a. Put here this v square upon 2a, this a and a is cancelled. What is the expression for kinetic energy? Half mv square. So this is the kinetic energy. Now the kinetic energy can be converted into other forms of energy. This expression for kinetic energy, how will you relate it with the momentum? You know what is the momentum? Momentum is mass into velocity of an object. If you put here this is mass velocity square, then you can write here from this expression V as P by M. Can you write V equal to P by M? Put here, then you will get K equal to half M and P square upon M square. This M will be cancelled. So, this expression says K equal to P square upon 2M. A very important relation for kinetic energy and momentum. How will you write it in another form? You can write P square equal to 2mk. So, P will be equal to under root 2mk. Now, in these expressions, you can find that if a heavy object and a lighter object, suppose this is A and this is B, its mass is more than this. So, if both have same momentum, suppose both have same P, whose kinetic energy will be more? This question is asked. Don't be scared of this question. Use these two relations. Same P, that means P is constant. Now look the relation, how K and M are related. Inversely, then for same P, K is inversely proportional to the mass. What does it mean? More will be mass, lesser will be the kinetic energy. Then as per the question, you give the answer. If it is A is heavier, then mass is more, then its kinetic energy will be lesser, provided both A and B have same momentum. In another case, if both are moving with same kinetic energy, then whose momentum will be greater? Use this relation. If K is constant, you can also use from here. If K is constant, then how P and M are related? Directly, how will you find? This P is directly proportional to root M. What does it mean? More will be the mass, more will be the momentum. So, look, if the two objects are moving with the same kinetic energy, one is of heavier mass than the other, then if kinetic energy is same, then heavier mass object will have greater momentum. If they have same momentum, then heavier mass will have less kinetic energy. So, in this way, the momentum and kinetic energy, how are they related? I have shown. Now, the very important theorem, work energy theorem. In the previous video, I asked the question that if there is an object which is moving in a straight line, its initial velocity and final velocity is given, how will you find what is work done by it? Then what is the amount of work done? You know, if you know only the work done formula F into S, you can't calculate. There is an important relation, work energy theorem. First, you know what is this theorem? The work energy theorem states that work done by a force on a moving body is equal to change of its kinetic energy. Learn one line. How will you write here? This work done equal to change in kinetic energy, that is final kinetic energy minus initial kinetic energy. So, work done by a force on a moving body, you learn here, is equal to change of its kinetic energy. How will you prove it? You know how the work is given? Initially, you know what is work done, force into displacement in the direction of force. What is force? Force is ma. How will you find the displacement? Suppose this is the object moving with the velocity u, after certain distance covering, its velocity becomes v, then this displacement covered in the direction if the force applied here is F, then how will you find acceleration A, S, U, V? Then look here, we have to find S. You will apply V square equal to U square plus 2AS. Then V square minus U square equal to 2AS. Therefore, S equal to V square minus U square upon 2A. Learn this relation. Then put here in place of S, how will you write? V square minus U square upon 2A. This A will be cancelled. What is here? This half m V square, open the bracket, minus half m U square. This half m by 2, that is half m, and this is V square minus U square. V is final velocity, that is kinetic energy in final position, minus kinetic energy in initial position. So, in this way work done is equal to change of kinetic energy. Various numerical problems are given where only the kinetic energy changes is given, and you have to find the work done. No force, no displacement. Due to change of kinetic energy, you can write difference of kinetic energy is the work done without knowing the value of F and S. Now, kinetic energy is also of 3 types. If you see the kinetic energy types, then it is translational kinetic energy, that is a car moving at a road, transfer of place. Translation motion means transfer of place. So, in a certain direction a vehicle is moving, it has kinetic energy, that is called translational kinetic energy. The second is rotational kinetic energy. How will you give the example of rotational kinetic energy? Due to energy possessed by an object due to its rotational motion. You know, Earth rotates about its axis. Earth has heavy amount of rotational kinetic energy. Fan rotates. So, spinning top, these are the examples of rotational kinetic energy. Next is vibrational kinetic energy. Vibrational motion, you know what is vibrational motion? To and fro motion about mean position. So, gaseous molecules or polyatomic molecules, they have rotational, vibrational kinetic energy both. Suppose a cycle wheel is doing the rotational motion as well as it is covering certain distance, then translational and rotational motion both. So, in this way you can give the example. How will you differentiate between this kinetic energy and potential energy? Learn potential energy is independent of speed and kinetic energy is dependent of speed. Kinetic energy formula is half mv square. What is potential energy formula? mgh. You have seen here, that is potential energy is the energy possessed by an object due to its changed position at rest or its shape or size. Now, what is principle of conservation of energy? Conservation means the quantity remains constant. This principle of conservation of energy says that energy can neither be created nor be destroyed. It can be converted only from one form to other. This principle of conservation of energy learn the statement that energy can neither be created nor be destroyed. It can be converted from one form to another. Suppose we apply this principle when we take the object which is at certain height h from the ground. Suppose this is the height h. It is situated at the point A from the ground. It has certain height, it is at rest. Which energy it will have? Potential energy, and potential energy at A will be mgh, where m is the mass of object. Since the object is at rest, what will be its kinetic energy? 0. Now if it falls freely, what we have assumed that in this free fall of an object, the total mechanical energy of the object will remain conserved. That is, potential energy decreases, then kinetic energy will increase by the same amount. And if the potential energy when the ball comes at the ground, then net potential energy will be converted into kinetic energy. So conversion of energy I am telling you, and the net potential, net mechanical energy is the sum of potential and kinetic energy, it will remain constant. Here at point A, suppose we have seen the mechanical energy, then what is mechanical energy? This mgh, sum of kinetic plus potential. At point B, suppose this is the distance small h, then what is the height left here? The total height is h, this is. Then what is the height of B? This is h minus h. Then what will be potential energy at point B? How will you write? mg h minus h. And what about kinetic energy? How will you find kinetic energy here? Here the speed was 0, but will the speed remain 0 here? No, it will gain certain speed. So now the potential energy will decrease and will be converted into kinetic energy. That is the speed gained. How will you find this speed gained? You will find, you know the relation v square equal to u square plus 2gh. How much h? From this to this point, that is this one, small h. Now initially the speed was 0, so it is 0. So 0 plus 2gh. So what is h here? This is v square upon 2g, or you can write v square equal to 2gh. What is kinetic energy formula? Half mv square. So half m, which v square? That is v at point B square. What is v at point B? 2gh. Then what will you write? Half m into 2gh. This 2 and 2 is cancelled. Again, what are you getting? mgh. Look, this is potential energy, this is kinetic energy. Therefore, mechanical energy is sum of kinetic and potential. Look here, mgh minus mgh. Here this is mgh. What will you get? This ub plus kb equal to again mgh, which was earlier. Similarly, when it is going to strike the ground, then that ball covers the height, total height h. Then you know, since from the ground it is just above the ground, no height, you will assume that potential energy becomes 0. Where it has gone? This potential energy is converted totally in the kinetic energy using the same relation. How will you find here? This vc square equal to this u square plus 2gh, u at A. Here we have taken B A. Here we can write B B. Look, u at A is this initial velocity was 0. This initial velocity, if you write here u initial velocity is 0, and this is the point A. Then How will you find here? This 2gh equal to V at c square, then kinetic energy will be half mvc square. Again you will get mg into 2gh. So this half m into 2gh, so half and 2 will be cancelled. So what will you get here? This kc will become mgh. So this is kinetic energy, potential energy, and this is kinetic energy kc. Again you will find that mechanical energy is uc plus kc, that is total energy mgh. What we have proved here, in absence of friction, we have not taken any air friction or any type of opposing force. So in absence of friction, the sum of kinetic energy and potential energy for an object falling freely remains constant. Same can be proved if you throw an object with the velocity v. Then initially kinetic energy will be half mv square, potential energy will be 0. Then at somewhat point here you will find the same half mv square, and here same half mv square. You will find that when the object is thrown up or it is falling down, the sum of mechanical energy remains conserved, and very important graph with the help of which this is explained. This is the graph where the energy and height is taken on y and x axis. Look, this is the graph for potential energy and this is the graph for kinetic energy. How can you explain this graph? Look, at this point, suppose this point is C at the ground where height is 0, and at this point in between, this is suppose B, and at this point at the maximum height, this point is A. I am relating this graph with this figure. Look here, at B this height, total height at A is h, then suppose here at B this height is suppose h by 2, and here then the energy will be mg h by 2. What will be the energy here? This mg h. I have taken this h here, then this capital H I have shown here. This is the total energy. So this total energy or mechanical energy, you can write, is the sum of kinetic energy and potential energy. This is A, maximum height position. What is kinetic energy here? 0. And at A, what is potential energy? How to draw this graph? You learned that at A, this at A, maximum potential energy and kinetic energy 0, sum is mgh, and at B, this is at height h by 2, we have seen, we can find mgh by 2. So in this way, this graph explains the potential energy graph is this. As height increases, potential energy increases. As height increases, kinetic energy decreases. So in this way, you can learn from this graph. Principle of conservation of energy is also explained by the pendulum. Motion of simple pendulum. You know what is pendulum? A spherical bob which is suspended by a light string, and it performs to and fro motion about its mean position. If the pendulum is suspended from light string in this way, then this is the position of the pendulum, suppose called mean position. Whenever it is displaced, then it attains certain height. Then suppose in this position the pendulum comes, then after this position it acquires the same height and it goes on the other side, then this is the second position. These two positions are called extreme position and this is called mean position. If you see the height acquired by the pendulum, the same height, suppose this is h, then this is also h. Here, since there is no height, then which energy is not there? Potential energy. Actually, potential energy is minimum. For our convenience, we take it 0. So, here potential energy is 0. Whenever from the mean position the pendulum is displaced, then it attains certain height where it stopped. Then position of rest, here it has certain height, then which energy it will have? Potential energy. How much? mgh. Since it is at rest, which energy it will not have? Kinetic energy. How much? 0. Then what is the sum? mgh plus 0. In the mean position, suppose from here it again comes towards the mean position, then it acquires the velocity. This velocity is suppose in this direction. This velocity how will you find? From falling height h, it acquires this velocity v, then you know v square equal to u square plus 2gh. Here the velocity u, initial velocity was 0, then what is v square? Equal to 2gh. Here you find the pendulum has velocity, then no height, potential energy is 0, but kinetic energy, you know what is the formula? Half m v square. Put the value of v square, what will you get? Half m 2gh. Then again you will find the potential energy and kinetic energy sum same, mgh. Same is here, again with the velocity v it goes and attains height, then its velocity decreases and at this extreme position its velocity becomes 0, but it attains certain height, then potential energy becomes again height into mg, this is mgh. And what is kinetic energy? Since it comes at rest, the kinetic energy is 0. In any position in between, its kinetic energy and potential energy sum remains constant, and we have seen in the mean position and in both the extreme positions how the mechanical energy remains conserved. So, in this way we can see that how the conservation of energy is applied if we have ignored the presence of friction here. We will see in two numerical problems how this conservation of energy takes place and what is the efficiency of a pump. Look in the first question. A hydroelectric power station takes its water from a lake whose water level is at a height of 50 meters above the turbine. Assuming an overall efficiency of 50%, calculate the mass of water which must flow through the turbine each second to produce power output of 1 megawatt. You should know what is efficiency. Efficiency is always power output upon power input. Look, how much is the efficiency given? 50%. 50% means 0.5, you know, 50 upon 100, 0.5. It takes the water from the lake up to height 50 meter. And what is the power output? 1 megawatt. Mega means 10 to the power 6. Put here the values. Power output is 10 to the power 6 megawatt upon power input. Water, suppose m kg water per second. Each second it is given, it is asked, and you suppose each second the water is taken m kg, then m kg into g is the weight of water, and into height. How much height? 50. What is to be found here? You take g equal to 10 meter per second square, then you put here the value of g also. Then how will you find m? You put here 10 to the power 6 upon this 0.5 will come here, this 0.5 into g's value 10 into 50. How will you get the answer? You can write 10 to the power 6 as 1000 into 10 to the power 3. Will it be or not? And here you can write this 50 into 50. How much? 25 into 20. You know this 50 into 5. 0.5 into 10 will be 5. 5 into 50 will be 250. Then 250 and 1000 you have already written here. It gives you 4. Then what will be the amount of water per second, mass of water per second? 4000 kg. It is asked that calculate the mass of water which must flow through the turbine each second. You should write each second. In this way you will solve. What about the second question? I will solve here. So look, it is given that a pendulum which is imparted a velocity of 5 meter per second from its mean position, and to what maximum vertical height it will rise on reaching at its extreme position if 40% of its energy is lost in overcoming the friction of air. What we have seen in case of pendulum, this is the mean position, this is the extreme position, and from mean position to this height is attained by the pendulum in going from mean position to the extreme position. Look here, at here this is the potential energy which is mgh. Here the total is the kinetic energy which is half mv square. This total energy is converted in the potential energy. That's why it comes at rest here. Or you can say whenever from rest it comes to the mean position, its velocity becomes maximum, then net kinetic energy is half mv square and potential energy, since no height, 0. So the total potential energy is converted into kinetic energy. It is given that velocity is 5 meter per second square. Then you write here this half m into this 25. But what happens? 40% of energy is lost due to friction. Then how much energy is retained? You know, if energy is 100%, then 40% is lost. How much energy? How much percentage? 60% is retained. Then you make the kinetic energy and 60% of that. Now this energy is going to be converted in potential energy at extreme position, that is equal to mgh. Mass is not given, it is not required. G is 10, you put the value, this 60% is 0.6, then how will you write? This 25 into 0.6 upon 2, and you bring G here, this is 10 equal to h. And this is the required answer. It is asked. You can solve here this 2, this is 0.3, this is 2.5, then you will get h as 2.5 into 0.3, that is 0.75 meter. So in this way you will solve the question, and whatever is the value given, use your mind that this energy is lost, then what is energy retained? 60%. So I hope you will be able to solve any type of numerical given. I hope you must have enjoyed it. Thank you.